Well students, now we are into section 2, the numerical value type section. Let's look at question 21 now. Question 21 says, a plane polarized light of intensity I0 is incident on a polarizer with its path axis making an angle phi with x-axis. When angle between the oscillating electric field of incident light and the x-axis is either 30 degree or 90 degree, the intensity of transmitted light is same and equals I. The value of I is Ni0. N is, okay, so the question is from the topic polarization, and let's assume that the path axis makes angle phi with x-axis. In fact, it is stated in the question. So let's say this is angle is phi and this is the path axis of the polarizer, right? Now the oscillating electric field, when it makes angle 30 degree with x-axis or 90 degree, the intensity of transmitted light is same. So suppose, let's assume that this angle is 30 degree. So when the electric field oscillation is along this line or when it's along this line, in either case the intensity of the transmitted light is equal. Now this angle is 90 degree minus phi and this angle is phi minus 30 degree. So it clearly means that 90 degree minus phi is equal to phi minus 30 degree, which gives us the value of phi as 60 degree, which means this angle is 30 degree only. So the intensity of the transmitted light I will be equal to I0 into cos square 30 degree, which is 3 I0 by 4. Now in terms of the format specified for this section, the value of n then will be equal to 3 by 4 in two places after decimal can be written as 0.75. So this will be the answer to question 21 as per the given format. Let's now move on to the next question. Question 22 says, a parallel plate capacitor consists of two circular plates of radius r separated by distance d. The capacitor is being charged by constant current I0. Magnetic field at point P at a distance r by 3 from axis is mu0 I0 by n pi r. N is, well, the question is from the topic EM wave and it requires application of concepts of the modified Ampere's law, the Ampere's Maxwell's law, and of course the displacement current, because we can see that in the space between the two plates there is no movement of charge, right? So there is no conduction current here, but there is what we call as displacement current, because the electric field in the space between the plates is going to change because of charging of this plate by constant current I0. Now it turns out that the total displacement current between the capacitors, between the plates of the capacitors, will be same as the conduction current I0. And if we consider a circle of radius r by 3 only, so the displacement current ID, which will be passing through this circle of radius r by 3, will be total displacement current, which is I0, which is same as the conduction current, and multiplied by the area of this loop divided by the total area, applying the unitary method. So the value of ID is going to be I naught into R by 3 whole square divided by R square, which is simply I naught by 9. Okay. Now there is no conduction current here, there is displacement current here. We can still apply the Ampere's Maxwell's law, and that when we apply that law, which actually gives us that integral B dot dl is equal to mu naught times IC plus ID enclosed within that loop. Okay. So in our case, IC is going to be 0, but we have the value of I naught, and the left hand side of this integral will be B into 2 pi R by 3, and the right hand side will be mu naught I naught by 9. Now this gives us B equal to mu naught I naught by 6 pi R. So if I compare with the answer, the value of N as per the given format should be 06.00. Let's move on to the next question now. Question 23 says, if the shortest wavelength corresponding to Lyman series is lambda naught, then largest wavelength corresponding to Balmer series is 36 lambda naught by N. N is, well, the shortest wavelength for the Lyman series we know is for the transition n equal to infinity to n equal to 1, which means 1 by lambda naught can be given as Rydberg constant R into 1 minus 1 by infinity, which is simply R. So this is one equation that we have, and now trying to find the largest wavelength corresponding to Balmer series. Suppose that wavelength is lambda, then 1 by lambda will be equal to R, and here the transition involved we know is, the transition involved here is from n equal to 3 to n equal to 2. That is the transition for which we have the largest wavelength in the Balmer series. So then 1 by lambda is R into 1 by 2 square minus 1 by 3 square. On simplifying, this is 9, this is 4, this is 36, or this is 9 minus 4, or this is 5R by 36. So this is our second equation. 1 by lambda is 5R by 36. We are interested in lambda, so we divide equation 1 by equation 2 and we get lambda by lambda naught equals 36 by 5. Or that means lambda is equal to 36 lambda naught by 5. So if I compare with the format given in the question, the value of N, again as per the format of the question, will be 05.00, because the value of N turns out to be 5. As per the given format, it will be written as 05.00. Let's move on to the next question now. And question 24 says, in the circuit shown, the current through Zener diode in milliampere is. So this is the circuit involving a Zener diode. We know this is used for voltage regulation, this kind of a circuit, and the Zener voltage is given as 6 volt. This resistance is 3 kilo ohm. So we know that the current here will be 6 volt divided by 3 kilo ohm, that means 2 milliampere. Current in this resistance is 2 milliampere. Now this applied voltage is 20 volt and this voltage is 6 volt. So this will be clearly 20 minus 6 or 14 volt. So that means current here the same current or this current will be equal to 20 minus 6 divided by 2, that means 14 by 2 or 7 milliampere. So if this is 7 milliampere, this is 2 milliampere, obviously this is 5 milliampere. Applying Kirchhoff's junction rule at this junction, and this 5 milliampere is passing through the Zener diode. So the answer to question 24 will be 05.00. Let's now move on to the last question of this test. Well, the question is based on ray optics, that to refraction. It says a rectangular metal tank filled with a certain liquid is as shown in figure. The observer whose eye is in level with the top of the tank can just see the corner D of the tank. The refractive index of liquid is root n. N is, we have to find the value of refractive index of the liquid. Well, the question is from the topic ray optics, and we see that ray starting from point D, it is going here at this corner, and it's going like this, okay, within the container. If we look at the dimensions, this is 3h, this is 4h, and this is 90 degrees, so this side will be also 5h, and the height of the container is also given as 5h, which means this angle is 45 degree, and after refraction the ray is going like this. That means the angle of refraction is 90 degree, whereas the angle of incidence is 45 degree. Now if I take the refractive index of the liquid is mu, then we have the equation sine 90 degree equals mu sine 45 degree, and sine 45 degree is 1 by root 2. That gives us mu is equal to root 2. But this is given as root n according to the question, which clearly means the value of n is 2. But as per our format, the value of n will be written as 02.00. So that is the answer to this question. Well, students, with that we come to the end of this quick solution. I hope you found the solutions useful. I wish you all the very best for your preparations. Take care. Bye.